Crystalline solids have a long-range order to their atoms or molecules, and the result of this is that we see these beautiful geometric shapes. We see crystals like this. This reminds me of Superman's hideout right up by the North Pole. This is a snowflake, and the beautiful shapes of a snowflake are caused by the crystalline structure of solid water. How do we find out what that crystal structure is? Well, X-ray crystallography is a technique that has made a lot of that possible. So if you remember, X-rays are electromagnetic radiation, just like visible light, but at a higher energy, and electromagnetic waves can interact with each other and form constructive interference or destructive interference. And if light passes through two slits, you can get an interference pattern that's produced. So in X-ray crystallography, we take advantage of that. The spacing between layers of atoms in a crystalline substance act as slits. And so we can shine a beam of X-rays. Here they're using a lead screen, so we just get a narrow beam, shining that on the crystalline solid, and that will diffract and have this interference pattern, and we'll get this diffraction pattern on the detector. And by studying the diffraction pattern and looking at the angle of incidence, we can get information about the spacing between the layers of atoms. Some of you will be really interested in this and many of you will not. I'm not going to test you on this derivation, but the idea here is that here's one ray that comes and it hits the top layer and gets reflected. Ray 2 passes through the first layer and hits the second layer and gets reflected. Those two rays travel different distances. And if the difference in distance here is just right, you can get constructive or destructive interference. The distance traveled is going to depend on this angle, theta, the angle of incidence. And so all of that to say, this comes down to what's called Bragg's law, where lambda, I don't know what happened to the rest of that. Oh, there it is. Lambda is the wavelength of the X-rays. D is the distance between the two layers of atoms. Theta is the angle of incidence. And N is just an integer, because this could happen if you go 2 layers apart or 3 layers apart, whatever. So there could be a question on the exam that requires you to use this equation. It will be given to you. You don't have to memorize this equation. And you don't need to really understand where it came from, although now you've heard about it, so I feel like I've done my duty. So typically what happens is we measure the angle at which constructive interference is produced, and then we calculate the distance between the two layers using a rearranged form of Bragg's law. X-ray crystallography has been useful in many, many different fields. The double helix of DNA was discovered using X-ray crystallography. We can look at proteins and other biologically important molecules, as well as simple ionic compounds. So an example of a Bragg's law problem, the spacing between layers of molybdenum atoms is 157 picometers. Calculate the angle at which 154 picometer X-rays produce a maximum reflection for n equals 1. So we'll pull these numbers out. We've got 157 picometers, and we've got 154 picometers, and we've got n equals 1. This is going to use Bragg's law, which is n lambda is equal to 2d sine of theta. And here what we're trying to find is theta. The angle is theta. So in this equation, we have the wavelength of the X-rays and we have the spacing between the layers. And so from the descriptions here, the spacing between layers is 157. So that's what D is. And when it says 150 picometer X-rays, that's referring to the wavelength of the X-rays. So that's lambda. So to find theta, we'll need to rearrange this equation. I'm going to divide both sides by 2D. 2's cancel and the D's cancel. I end up with the sine of theta is equal to n lambda divided by 2 times D. So we'll go ahead and plug the numbers in here. And the units are going to cancel out. So 154 divided by 157 divided by 2. It's always better to keep extra digits, especially when you're dealing with weird functions like logarithms and sine and inverse sine and things like that. The rules for sig figs become a little bit complicated there, and so it's just better to keep some extras. So what I've got here is that the sine of theta is equal to this number. How do I undo sine? Inverse sine. So sine is a function, like multiplication is a function, so we can't just divide by sine because it's not a thing. It's a function. We have to undo the function. So theta is equal to the inverse sine of that number. I have the number still in my calculator, and so instead of typing it in again, I'm just going to use the memory function here, and I get 29.4 degrees. It's important that your calculator is using degrees and not radians or grads, because that'll make things really crazy. Any questions? Yeah. That's a good question. Why did I assign these the way I did and not the other way around? So the sentence here says the spacing between layers is 157. And so that's the definition of D. If we go back and look at this, D is the distance here between the two layers. Okay? And lambda is the wavelength of the X-rays. And this is not specifically saying that these X-rays have a wavelength of 154 picometers, but the fact that the number and X-ray is right next to each other says that those go together. Yeah. Any other questions?
How do you pronounce that word?
Molybdenum?
Molybdenum?
Molybdenum. Yeah. That's a fun one. Molybdenum. Yeah. Any other questions? Yeah, 29.4.